The airworthiness of an airplane is determined in part by the following certificates and documents, which must be on board the airplane when operated. The way most pilots are taught to remember this is with the simple acronym AROW, A-R-O-W, which stands for Airworthiness Certificate, Registration Certificate, Operator's Handbook, and weight and balance documents, including an equipment list. In addition to these documents, a safe flight begins with a careful visual inspection of the airplane, referred to as a pre-flight inspection. The purpose of this inspection is twofold. First, to determine that the airplane is legally airworthy, and secondly, to determine if it is in a condition for safe flight. The pre-flight inspection should be performed in accordance with a printed checklist provided by the aircraft manufacturer for the specific make and model of the airplane you're about to fly. The purpose of this video is to show a pre-flight inspection following general guidelines applicable to most airplanes. It is very important that you follow the specific instructions given by the manufacturer of your aircraft, which can be found in the flight manual. The pre-flight inspection can be performed inside or outside the hangar. You will need access all around the aircraft with adequate light to do a good job. The pre-flight inspection should begin while approaching the airplane. Some problems can be identified more easily from a distance. The pilot should make note of the general appearance of the aircraft, looking for any obvious discrepancies such as landing gear alignment, tire condition, structural distortion, skin damage, and fuel or oil leaks. All tie-downs, control locks, and protection covers should be removed. We've chosen to pull the airplane out of the hangar for this pre-flight inspection and will now remove the tow bar before beginning. A proper pre-flight inspection will require the following: a fuel sample tester, generally stored inside the aircraft, a receptacle for proper disposal of fuel, and a rag or paper towel. The first step in performing a detailed pre-flight inspection of the aircraft is to lower the flaps. In order to do this, the master switch must be turned on. Anytime the master switch is turned on, you should make sure no one is near the propeller area. This is important because in certain rare circumstances, propellers begin to turn when the master switch is turned on. This is due to certain electrical malfunctions of some aircraft. Once the master switch is turned on, lower the flaps by placing the flap lever in the down position. It will take a few seconds for them to fully deploy. While they are coming down, make a mental note of the fuel gauge readings and then turn the master switch back off to conserve electricity. The exterior inspection begins upon exiting the cockpit. Your objective is to inspect the entire aircraft for signs of damage, deterioration, or wear that would affect its airworthiness. You will also be looking at fuel and oil levels as well as the general condition of tires and brakes. During this inspection, look for areas of concern that may include missing or loose screws, rivets, or other fasteners. Areas of structural damage where skin or structure is deformed, cracked, or misaligned. Look for streaks and stains from leaking fuel or oil and check all movable items for smooth and quiet operation. Any question of airworthiness should be satisfied. A pre-flight must be completed before every flight. Occasionally, a pilot finds something wrong that has been missed on dozens of previous inspections. Subtle changes occur over time that may be age or wear related and are easily overlooked. Hangar rash, wind damage, or towing incidents occur and need to be spotted. Fuel and oil leaks develop and need to be addressed. Failure of components that occurred on previous flights need to be found. So take your time and be observant and come to know your aircraft. With that in mind, start your inspection by moving toward the tail down the left side of the aircraft, looking things over as you go. Walk around to the left side of the stabilizer and with a firm but gentle grasp, flex it up and down and forward and aft. Be on the lookout for looseness or unusual popping or oil canning of the skin. This could be an indication of internal damage. Now grab the left side of the elevator and move it up and down through the limits of its travel. It should move smoothly without binding or noisy operation. Inspect the bolted hinge points to ensure all nuts, bolts, and cotter pins, if used, are installed. Look at the elevator stops and make sure the elevator controls make solid contact with them and that they are undamaged. Look at the stabilizer and elevator from both above and below and observe the general condition. Look for any signs of damage or areas of concern. The rudder can be moved left and right now. Try to move it by pushing on structure rather than by putting pressure on the fragile trailing edge to avoid damage. There will be some resistance because the rudder is usually interconnected to the nose wheel steering mechanism. Like the elevator, the rudder should move smoothly throughout its range of travel and should also make contact with the stops located on the aft lower portion of the fuselage. Inspect the flight control cable attach points for both the rudder and the elevators. These are connected with a clevis type attachment and have hardware with cotter pins installed. Make sure they are present and allow rotation. Also look at the flight control cables as much as possible to ensure no fraying is occurring. Look up at the top of the rudder and vertical fin and observe the nav light and beacon to make sure they are intact and appear operational. The right elevator and right side of the stabilizer is inspected the same as the left with one addition, the trim tab. It should be securely attached to the elevator with a piano hinge and a control rod. A gentle shake and verification of fasteners is all that is required. Moving forward, inspect the skin and structure of the tail cone as before and arrive at the inboard section of the right wing. Here we will collect our first of 3 fuel samples. Locate the fuel drain on the bottom of the wing towards the back. This is the lowest part of the tank where any water or contaminants will accumulate. With the fuel sample cup in hand, insert the rod into the drain valve, push upward and release a small amount of fuel into the cup. The fuel should be clear, free of sediment and water which can accumulate due to condensation. In the United States, the only widely available aviation gasoline, or avgas, is 100 octane low lead, or 100 LL. It has a blue color added by manufacturers for identification purposes. It has a unique smell, unlike automotive fuel. You should become very familiar with this smell and be able to recognize it. With clean fuel in the tester, let's add some water to demonstrate the separation of the 2 liquids. It's very obvious to see that water is heavier than fuel and settles to the bottom quite quickly. If large quantities of water have entered the tank for any reason, you can be fooled when testing the fuel. This is why it is so important to look for the blue color as well as smell the fluid to verify it is indeed fuel and not water or anything else. After inspection of the first fuel sample, dispose of it properly into a designated receptacle. Examine the right wing flap, paying particular attention to any loose bolts, cracked or broken tabs, roller condition, or distortion of the flap itself. The flap track should be clean and smooth, and the flap should rattle around a little bit as you shake it. The flap on the right side is directly connected to the flap motor and will feel solid and secure when pushed upward. The left side flap is connected to the right side with cables and will feel slightly less solid when pushed up because of slack and stretch in the cables. Move out now to the aileron and gently move it up and down. You should hear the stops make contact inside the wing. The hinges should have little cotter pins at each end to keep the hinge pin from migrating out. Verify the control rod is secure and rotates freely and that the counterweight is in place with good rivets. Continue to trace around the edge of the wing, examining the nav and strobe lights. The wingtip is made from plastic, and it's common to have small cracks. They should be stop drilled by a mechanic to reduce the potential for the crack to become longer. Moving along the leading edge of the wing, you will notice a fuel vent behind the wing strut and air vents located in the leading edge of the wing. Make sure they are free of obstructions. Shake the wing strut to make sure it is secure and follow it down to the wheel assembly. Check the tire for proper inflation and tread wear. Look at the sidewall and down into the tread bars for weather checking and cracking from deterioration. Take a look at the brake pads and verify that they are not worn out. Look for any leaks around the brake caliper or abnormal discoloration of the disc indicating overheat damage. Make sure the axle nut that holds the wheel in place and the cotter pin is installed properly. Now shake the wheel and tire assembly vigorously and make sure you see no movement between the wheel and the axle. Carefully make your way up to the top of the right wing. Visually assess the contour and shape and general condition of the wing. Open the fuel cap and look inside. You should hear no air rushing in or out when you open the cap. This would indicate a venting problem and would be cause for a mechanic's investigation. Determining the accurate fuel level is most easily checked with the use of a calibrated stick. You can buy one with a hollow center that works by dipping it in the tank and holding your finger over the end as you withdraw it, and then read the level on the stick. You can also fabricate one yourself from a wooden stick and mark it as a fueler incrementally fills the tank. Whatever your method, be sure to obtain a conservative calculation of the fuel on board. Now make certain you reinstall the fuel cap securely. You will know it is on correctly when the tabs are streamlined. If caps are forgotten to be installed or come off during the flight, fuel will be drawn out of the neck of the filler during the flight. This is a result of the low pressure created from the wing and can quickly siphon a lot of fuel into the atmosphere. Double checking the cap should be part of your routine. After descending from the wing, examine the fasteners along and around the cowling. An access door provides a place to check engine oil. Open the door, unscrew the dipstick and pull it out. Now you can wipe it down, reinsert and extract to see the oil level. Be careful not to drip oil in or around the cowling area. A small amount of dripped oil can make a mess and be mistaken for an engine problem. When returning the dipstick and securing it, do not over-tighten. Near the dipstick is a knob labeled Fuel Strainer. The fuel strainer is the lowest point in the entire fuel system, and a small amount should be drained into the sample cup. This is a little awkward because of the location of the drain, but will give you the opportunity to examine the fuel again and evaluate it. The propeller should be carefully checked for nicks, cracks, pitting, corrosion, and security. Nicks come as a result of the engine run-ups over loose gravel. The propeller will create a mini tornado on the ground about 18 inches in front of it when it is run at higher RPMs. In this clip, we see the evidence of this as the propeller picks up water during a run-up. Be cautious over small rocks and loose gravel in the vicinity of your run-up area. If you see dings in the propeller more than about 3/16 of an inch in diameter, you should have a mechanic dress the prop before flight. Inspect the propeller spinner and spinner mounting plate for cracks and security and signs of chafing of the blades. Look inside the cowling and check for loose or foreign objects, such as bird nests, shop rags, and tools. Check for oil leaks and examine the tension and wear on the belt. All visible wires and lines should be checked for security and condition. Below the engine cowling is the nose wheel. Note the condition of the tire and look at the strut assembly. There should be 3 or 4 inches of shiny strut area exposed, indicating proper strut extension. Look over the entire assembly for loose and missing hardware, damaged components, and red hydraulic fluid leaks. Remember, the nose gear assembly is a fragile part of the aircraft and should be inspected closely. On the left side of the forward fuselage, you will see a static vent. This should be unobstructed and clean. Some people place tape over these ports when the aircraft is washed and occasionally forget to remove it. This will render the altimeter, vertical speed indicator, and airspeed indicator useless, so be sure to check these ports. Now make your way up to the top of the left wing and observe the condition of the upper surface of the wing and check the fuel level. Again, make certain you determine the amount of fuel you have and that it corresponds with the requirements of the flight. Don't forget to install the cap, and then move back down to the left wheel. Again, looking at tire condition, brakes, and general condition of the assembly, including proper inflation of the tire. Look at the big nut and cotter pin and shake the wheel assembly. Now start making your way down the left wing. You will notice one difference from the right wing in that there is a pitot tube located just outboard of the wing strut. This is the air source for the airspeed indicator and should be free and clear. Never blow into the pitot tube because you can easily destroy the sensitive airspeed indicator. You will also notice a port in the leading edge of the wing near the wing strut. This is a stall warning port. This aircraft uses a pneumatic horn that simply works by air flowing through it. The rest of the wing is inspected in the same fashion as the right side, looking at the tip and lights as well as the aileron and wing flap, verifying proper hardware is installed and no unusual noise or binding occurs when they are moved. Look for any visual signs of distress or damage. As you return to the cabin door area, you will take your last fuel sample and again confirming the familiar avgas scent, bluish tint, and absence of water. Some thought should be given to the cleanliness of the windows before flight. If cleaning is necessary, use products designed for plastic aircraft windows and make sure to use an appropriate soft towel so the plastic is not scratched or damaged. Take a few moments to open the flight manual and review the items in the pre-flight checklist to ensure nothing was missed. Don't take this task of the pre-flight inspection lightly. Not only does this ritual get you in the right mindset for the flight ahead, but it is also your time to identify any problems that exist and deal with them on the ground so that they are not an issue when you are in the air. The exterior pre-flight visual inspection is now complete. It's time to step into the cockpit.